Hello everyone, I'm Singh studying PhD in computer science. Today I will talk about the facial expression recognition using convolutional neural networks. Let's talk about the introduction. In 1971, Albert Maharabian published a book called Silent Messages, where he shows that only 7% is a verbal communication and rest of the 93% is the non-verbal communication, which also shows us that how the non-verbal communication is important in our social communication. Why the facial expressions are important? Humans display their emotions through facial expressions. Emotions are a very powerful and a challenging task in the social communications. That's why we are teaching computers to read facial expressions. Let's talk about the background. In 1862, there was a French neurologist who always wanted to understand how the face muscles work to produce facial expressions. He believed that the facial expressions linked to the human souls. He used electric probes to determine that. Later, in 1872, Charles Darwin used his work and introduced in his book called The Expressions of the Emotions in Man and Animals. Let's talk about my research. This dataset contains 7 different emotions and it's publicly available, which includes angry, disgust, fear, happy, sad, surprise, and neutral. So let's talk about the facial expression recognition pipeline. We have the input images, we do the face detection, then you perform the illumination correction. When you click a picture in a very bright light, your pictures get blurred. In order to improve the quality of the picture, we perform the illumination correction. We do the feature extraction, where you extract the most prominent part of the face, like eyebrows, eyes, nose, mouth, and the jaw. Then we feed these images to the convolutional neural network, which is a very complex and it resembles like a human brain. So let's see how a neuron works in a human brain. It has a different layers. First is dendrites. Dendrites where all the input occurs. So the next is axon. Axon is a fine long projection carries a communication or a signal from one neuron to another neuron. And the last is synapse, where the all actual communications takes place. After feeding these images to the convolutional neural network, it classifies the different emotions like angry, disgust, fear, happy, sad, surprise, and neutral. So let's talk about the results we have studied so far. The number I encircled, the computer predicted almost 44% as a fear correctly and almost 50% as a sad as compared to the other emotions. So let's talk about the misclassified images. On the left hand side we can see the actual image is sad, and on the right hand side we can see our computer predicted as a fear. And in the bar chart we can see on the x-axis we have the different emotions, and on the y-axis we have the percentage. So the facial expression recognition can be used in very vast domains like traffic safety, e-learning, monitoring, and social humanoid robot. So the challenges we faced are the publicly available data set. We have the very minimum quantity of numbers of the images, due to which we face hard to train a model, due to which it leads to the lower in the accuracy. To address this issue, we introducing the generative adversarial network, in short GANS. In the GANS, we have two different neural network. One is a generator and another is a discriminator. So generator basically learns to make fake images that looks like very real, whereas the discriminator learns to distinguish the real images from the fake ones. These are the example of the generated images, whereas and discriminator is distinguishing the real images from the fake ones. And in the purple box you can see all are the fake ones, and in the green box you can see the real ones. So when this game is going to end, when the generator is producing more and more fake images which looks like a very real, this game is going to end there. The GANs over the time is producing more and more realistic images and in the high quality images, and you can see in 2014 we started from the grayscale images, and in 2018 it's producing the high quality color images. And still so far till now and the GAN is producing more and more realistic images. And see, you can see in the very high definition images. And what if I say that these people do not exist? The GAN also work in the MNIST dataset, which is very renowned and contains the handwritten digits. And the left hand side we can see the ground truth of the MNIST dataset, and on the right hand side there is a deep convolutional GAN which produces more and more fake images which is look like a real, like a ground truth. GANs are using in the very vast domains. The companies using GANs like Adobe using GAN for the next generation Photoshop, Google using GANs for the text generation, IBM using GANs for the data augmentation, Snapchat and TikToks using GANs for the image filters, Disney using GANs for the super resolution images. These are the references. Thank you.